Let's now continue from last time. So we talked about polymorphism and dynamic binding. So we review the rules as we go. So we have to build the story to be a little bit more complete. So we only told half of the story last time, so we're going to complete the other half, hopefully today. Let's just review this example very quickly and then to see what to learn. First of all, in line number 1 here, we declare Jim to be of a student type. So the static type of student is for Jim is students. And then with the dynamic type, after executing line number 1, should be resident students for Jim. Okay? And then we say that line number 2 should not compile, because the way to judge, whenever I ask you whether one line should compile or not, you should only look at the static types of the both sides. In this case, the static type of Jim, which is students, is not a descending class of the resident students on the left-hand side, right? You can see that according to this hierarchy over here. Okay, we'll see another example in the next slide. Line number 2 should not compile. However, you can see that the compiler is not very flexible over here, because what we have over here, let me just remind you how you can draw this. Okay, you can see that over here we have Jim is now pointing to a object over here, and the object is of type resident students. I'll put resident student over here. And then the resident student should have some premium rate attribute here available to be set to be something over here. However, the compiler tells us that it doesn't know. It doesn't know about the dynamic type of Jim at line number 2 being resident students. It simply cannot tell in general, as I said before. It's an undecidable problem. But we really want to do things like line number 3, because we are pretty sure that Jim is really pointing to a resident student object. So now in this case, what can we do? So there is a way for you to do this to really force the compiler to believe what you really believe is correct. However, it will be checked at the runtime. Okay? So let me just show you what we can do. And then I'll go over 2 examples first, and I'll tell you what the general rules are. Okay? Okay, so we talk about line number 1, we talk about line number 2. Okay? And now basically this is what we got so far from last time. Now, how do we force the Java compiler to believe the dynamic type of Jim at line number 2 is really compatible with resident students? How do we do that? We can do a cast. It's a little bit like how you can cast from double into integer for primitive type, but now we do the cast in context of inheritance. How can we do that? Let me show you the syntax first. The syntax is very similar to what you did before. Okay? Let's say over here, we got resident students. Okay. If you compare line number 2 over here with the new line over here, compare with these 2 lines, the only thing we added was we inserted between the equal sign and Jim, parentheses, and then a type. In this case, resident students. Okay? So what do we mean by that? Let me first of all tell you what the consequence is. We are trying to tell the Java compiler temporarily change the static type. What I said last time was the static type never changes. It never changes permanently. However, you may modify that temporarily. This is the case. Okay? Let me first of all just tell you verbally, and that will illustrate that. We are saying that Jim was declared of static type students. However, since I'm very sure that Jim is now pointing to a resident students, so what I can do is to make the type checking happy, I can temporarily change the Jim static type into resident students. Okay? If I change that, what does that mean? That means now the right-hand side, the static type is resident students, not students anymore. In this case, resident students is a descendant class of resident student on the left-hand side. So now the type check will just pass. Okay? Let me just illustrate to you what this really does. Okay, again. Okay, let me just go to iPad. So let me just do another one. Okay, so now this is what we write. I'm going to write it out. So we have over here resident students and then we say RS is assigned to also resident students and then Jim. Okay, let's see what this does. Let's try to break down the expression into several parts, okay? If you only look at, let me use green. If you only look at this part here, just Jim by itself, Jim has the static type, as we can see from the previous slides. Jim was declared to be students, okay, as we can see, right? But the problem before was students is not a descendant class of resident student. That's why the previous compilation failed. But now we can actually somehow force the compiler to believe. Okay? The way we do this is by using a cast. So now the one I'm going to highlight in green over here, this is the new but temporary static type for Jim that I can do. Okay? So now we have a new expression over here. If you have something like this, so now if we say resident students with parentheses apply to Jim, so this is a new expression. Okay? This expression here has a different static type. Now the static type is simply whatever this is, resident students. Okay, so once we have done that, you can now, let's do the type checking again. So now you can see the new static type is simply just resident students. Is resident students a descendant class of resident students? In this case, yes. So this will make things compile. Okay. However, we still have to see why this will work in general. I'm just giving you one example. Okay. Now, one more thing to say. Okay, so now that means we used to have Jim that is pointing to a resident students objects over here with some premium rates over here. And after this assignment over here, star, okay, after that, we actually got RS that is also pointing to this resident student objects, just because we did a cast, so we could do it. Without a cast, you just cannot. Okay. Now, let's just look at the next line. If you look at line number 3, when you say RS does set premium rates, in this case, you will do things properly, because now RS is now pointing to some resident student objects. You want to set the premium rate to be 1.5, you will just set it to be 1.5. But if you try to do this like before, if you say Jim dot set premium rate, like one of you guys asked me last time in the class, if you simply do this, it will not compile. Because again, to see if things will compile, you look at only the static type. In this case, we know that the static type is students. And ask yourself, does students have this set premium rates method? No, it doesn't. So this one does not compile. Okay? This one does not compile. Okay? Now, one more thing to show just about the syntax, which is also summarized in the later slides. Now, we can somehow make the expression a little bit shorter if you want to. Okay? Let me just show you how you can do that. Okay? Let me just add another page, and then I'll show you some shorthand. It's completely up to you which one you would like to use. Okay, add a new page below. Okay, let me just do it again. Okay, again, we have students. Thank you sorry about that. Students, we have Jin, and that is, I'll just say RS. It's a new resident students, something over here. Okay, that's what we begin with, and that is some static type students. Okay, so let me show you 2 ways of doing things. Approach number 1. Approach number 1, you can declare a new variable here, resident students, and then I can now cast. Let's say RS is, now I cast Jim into RS, and then Jim. Yeah, they look different, but they are really the same. Okay, I just used shorthand. Okay, this is as I explained from the previous slides. And then you can say RS does set premium rates to be 1.5. Okay, let me show you another way to write this, which is completely equivalent. We can say, I really don't quite like this intermediate variable. It can be a little bit inconvenient for you to write. What you can do is as follows. You can say, let's now try to cast Jin. RS and then Jin. So this is going to create some expression whose static type is resident students. Okay? And then I'm going to say bracket that, and then I can say dot set premium rates, and then 1.5. So these 2 expressions are equivalent. You can use either one. Okay? However, there's a common mistake. If you try the following, let's say it's going to be very similar to the number 2. So now I'll say number 3 over here. If you try RS, resident students, and Jim, and then you put set premium rates 1.5. This guy here is not going to work, simply because in terms of the precedence, you can think of set premium rates like multiplication. Cast is like addition. So if you write something like this, it's as if you put a bracket around Jim and then the set premium rates. Okay, it's as if you did that. Okay, so what it will do, so it's as if, I'll just put brackets over here. It's as if you did something like this. So now we already knew that gym.setPremiumRate simply wouldn't compile. And then you're trying to call the method before you do the cast. But you should really do the cast before you call the method. Okay? So number 2 and number 3, they are different, even though they look very similar. Okay? Number 2 will compile, but number 3 will not. Questions? Yes? RS equal to gym. Okay. Right? Remember, okay, the question was, if I simply say, okay, let's go back here. You're basically talking about why can... Oh, but it's different, right? Because now, okay, I see what you mean. Okay, let's see this. I'll go back to iPad here. But the thing is, we started with some student objects, right? Okay, let me see this. So remember, we started with an object called students, right, of type students. And then we have gym. And then it can be, in this case, we just put some resident students over here. Right? In this case, you can see that, I'm not too sure. So if you just got another, let's say, student over here, and then you can say, for example, just students. In this case, you can do it, because if you say S is assigned to gym, in this case, that will be okay, because the static type of the right-hand side, right? What's that? That's students. Students. And what is the static type for S? Also students, right? So this will be okay, right? So because student is a descending class of itself, okay? Yeah. Maybe try to see more examples as I present today. Hopefully that will answer your question. Okay. Any questions before I move on to a second example to show you very quickly? Are we okay? Yeah. Okay, that's about this example here. So this is about the student resident students. Let's now consider our smartphone example, okay, very quickly. Let me show you the classes you should pay attention to in this case over here. Okay, so let me just show you again the hierarchy for us. So remember, at the top, we actually got a smartphone over here. Okay, first of all, you can see that we declare smartphone, a phone, to be a new, and then the dynamic type's iPhone 6s Plus. In which case, let me just also annotate that. So green one means the static type, and the pink one means the dynamic type. So now you can see that this assignment over here should compile, right? Because iPhone 6s Plus is a descending class of smartphone of the left-hand side, right? This is a descending class of that, okay? And now, if we try to do something similar, let's say we declare iOS, okay? Now we say iOS for here, and then we say a phone. In this case, do you think that will compile or not? Yep, I can do that. Okay, also we got another class over here, so we say iOS, okay? So now we say iOS for Hyun over here. Okay, we say that is equal to a phone, okay? And just to remind you, this is a static type for a phone, and this is the dynamic type for a phone, okay? Do you think this assignment here will compile or not? No, right? How do we judge? Again, similar. What's the static type for a phone? The green one, right? Smartphone. Is smartphone a descendant class of the static type for Hyun? In that case, it's iOS. We're asking, is smartphone a descendant class of iOS? No, it's not. Right? You can see iOS is over here. So it's not. Okay? So basically, every time if you want to judge if a line compile or not, you should really have the inheritance hierarchy handy. And then just do the judgment. It's the right-hand side, the static type, a descending class of the static type for the left-hand side. That's what you got to judge. And the rationale we talk about is really about expectation. Okay? You can always expect more on the descendant objects compared with its ancestor objects. That's something you should really review. That's really the rationale. Today is mainly about applying the rules to see how things work. Okay? So you can really understand some complicated code. Okay, so now, I'll leave the rest to you. Okay, so this example here basically the same, because even though we know that a phone is really pointing to an iPhone 6s Plus object, but we simply just cannot do line number 2, because a phone static type is smartphone, which is not a descending class of iOS. We know that it wouldn't compile, but we are so sure it should be okay. So what we can do is we can do a cast. Okay, you can see that. I'll just show you the cast over here. Okay, you can simply say iOS for Hyang, and then we just add this iPhone 6s Plus cast over here, as we did before. Okay, and then you will compile because now we temporarily change the static type for a phone into iPhone 6s Plus, which temporarily changes that. And then now this new static type is a descending class of iOS, okay, as you can see. Because you can see iPhone 6s Plus right now is a descending class of iOS. It is, so now it's okay. Okay. Of course, you have to go over the slide after the class. I wouldn't expect you to follow completely, but hopefully you see the big picture. Okay, guys, any questions about this before I move on? The last point over there is about dynamic binding. So basically, what I'm trying to say is this. So similar to the previous case where we got the student objects, I'll just show you something here. So now over here, after the cast, we know that for Hyang, over here is going to point to some iPhone 6s Plus object over here. So now, when we try to call line number 3, we know that it is now pointing to iPhone 6s Plus objects. In which case, of course, when we call FaceTime, it's going to call that version there in the class, right? Again, when you see the hierarchy here, you can see the FaceTime over here is a method defined in iOS. Somehow it will be inherited into this class over here, iPhone 6s Plus. Okay, so you're going to call that version there. Okay. Are we okay, or can we move on? Okay, things will get worse. Don't worry. So you better ask me a question before it get worse. Okay, I don't want everybody to be completely lost today.
The question is, when you say by casting, we change the static type.
Only temporarily.
Temporarily. So, like we are casting like my iPhone before Hyang. So for Hyang, storing different static type.
You know what? How about this? Let me go over the next slide. So these two slides are only examples to give you a feel. Of course, you cannot just learn about casting in this way, just by two examples, no way. So in the next slide, I'm going to tell you what's the general rule for you to do cast, okay? How about save your question for, if you still got one, you can ask me maybe after the next slide, okay? Okay, so now the next slide, I'm going to show you the general rules, give you some intuition. The slide itself, so this is just the syntax. Okay, I just talked about it. You can simplify that in the common mistake. So now, what's really the general rule for you to cast? You cannot just cast an object to any class. You cannot just do that. Let me give you some intuition. First of all, you should really understand what's really static type. Static type is what you declare a variable to be, and the static type determines the expectations you can have on the variable, right? If you declare the static type to be students, then you can only call the student-only attributes or methods. If you declare the static type to be resident students, in that case, you have more expectation. For example, premium rates and set premium rates. Okay, that's kind of the idea. Now, when you want to change the static type temporarily using cast, now the intuition is easy. I can either try to, so whenever you're trying to change a static type, that means you're changing the expectation. Now, which direction are you changing? Are you trying to make the expectation narrower than before or wider than before? Okay, that's really the question. Okay, I'll give you some, I will show you on the picture and then I will show you the rule. Okay, let's say over here, let me go by the iPad here. Let's say, for example, let's say now I declare a variable, let's say Android. Okay, I'll just say Android phone. How about just phone? Okay, it's gonna be equal to something here, okay? At the moment, it's not important, okay? I'll just ... So now we know that the static type for a phone is simply Android. Let me just mark that in the hierarchy here. So this is static type. Now, I want you to visualize what kind of cast can you do. So now, we know that for a phone, the current expectation which I declare to begin with is only Android. So what are the expectations? Let's review that very quickly. What's the expectation? So we got, for example, I'll circle that. We got dial, we got surf web, also we got Skype. However, it does not include things like site sync. It does not, right? Because that's a Galaxy only feature, right? Also, we also don't have FaceTime either. Okay, that's the expectation to begin with. Surf web. This is just another branch, which is not, so that one is simply inherited from over here, right? I said, yeah, surf web, yeah, as well. I'm just circle the name, right? Yeah, okay. Now, if I want to change the expectation for this particular phone, I can either try to make the expectation less, or I can make the expectation more, okay? How can I make the expectation less? It's so-called upcasting. I can cast a variable to be its ancestor, okay? So now, let me first of all tell you what kind of classes you can cast that into. So these are the things you can cast that into. So I'll circle them. These are the things you can cast that into. Okay, first of all, we can see that the only branch that's not included is this branch here. You cannot. Okay, let's see why. Okay, let's try to cast. Let me just give you some idea over here. So now let's say this. If with just the phone, what can I do? I can say phone dot dial. I can say phone dot surf web. I can also say phone dot Skype. So these are okay. Okay, first of all, okay. So far so good. Now, let's try to make the expectation less. What can I do? First of all, I can do so-called the upward casting. Okay, so now let me use maybe yellow over here. So this is upward casting. Okay, upward casting. So let me try that. So this is okay. So let me say green. So what I can say is smartphone over here. Okay, I would say SP, smartphone. And now I can do the cast. I can say I will cast the phone into smartphone. Okay, this is fine. How do I know it is fine? It's because the type I'm trying to cast into is an ancestor class of the type over here. Oh, let me say it again. Let me undo, okay? Let me say it again. How do we judge? First of all, we know that for the phone over here, the static type is Android, okay? And how do I know that this cast is actually okay? It's because the smartphone over here is an ancestor class of its static type Android, right? Because smartphone over here is an ancestor class of Android. That means we are trying to narrow down the expectation. How? Can I still call, for example, let me use green over here. Can I still say SP dot dial? That's fine, right? Okay, good. And can I say SP dot surf web? That one also fine. However, can I say SP dot Skype? No, not anymore, right? Right? This one no longer possible because now the static type has been changed to smartphone. And smartphone does not support the Skype, which is down in the Android phone. So this is one kind of cast you can do. You can try to narrow down the expectation. You're trying to make the expectation strictly less. Okay? Now, you can go the other direction as well. Going the other direction means you're going to go to descending classes. In this case, you can cast Android over here to any of the descending classes. I'll show you one example. Okay, what you can do is I'll use red over here. Okay, I just running out of space. So what you can do is over here, I'll just put it on the top. Okay, so what you can say is, let's say we are trying to cast that into what about Galaxy S6 Edge Plus. Okay, if I do that, that means I will say Galaxy S6 Edge Plus. Okay, and then I can say Galaxy GA, and then I can say that is assigned to, and then I can do a cast. Galaxy S6 Edge Plus, and then I can cast phone over here into it. Okay, that's another possible cast. It's called a downcast. Okay, now let's try to see why this cast would be okay. You can either do upcast or downcast. Upcast to some ancestor or downcast into some descendants. Let's see that. First of all, how do we judge that this line should compile? Let's see that one by one. You can see that, first of all, the static type for phone doesn't change. Okay, it's still enjoyed. Okay, as we can see over here from before. And then you can see that the type we are trying to cast that into, which is Galaxy S6 H+. In that case, you can see this is the static type for phone. And this is the type we are trying to cast that into. And this is a descending class of that. So that's fine. Okay? So that's okay. Now, what's the consequence of this? Right? The consequence is, can we call more methods the same or fewer methods? More, right? In this case, right? So now, if you try to use GA over here, if you say GA here, of course, you can still say GA.dial, GA.surfweb, and GA.skype. That will still be okay. Now you can say one more thing. You can say GA.sitesync. Right? So now we can call strictly one more method after this cast. Okay? You can see so far, this one thing I intentionally leave blank, which is the dynamic type. That's intentional. Because for now, this particular page, I'm only talking about what can compile. I haven't talked about if given that a cast compiles, is a guarantee have no runtime exception. It turns out it might have exception at the runtime. That's something we'll talk about in just a moment. Okay, there's something I want to mention to you. So if you go to the lectures page, there is an additional notes PDF. So that one talk about exactly upcast and downcast using a smaller example. Okay, I think you should really go over that to see the story as well. Okay, now I'm just trying to illustrate using this one here. Guys, any questions? To summarize, when you want to do a cast, you can either do upcast or downcast, either way. Yes, exactly. Either to ancestor or descendant. Now, let me follow up by this. Okay, let me just double check. Now, let's say again, if I say enjoyed over here, let's say phone. And now, let's not worry about dynamic type. It's not relevant. Okay. Now, if I say I have iPhone 6s, and then iPhone 6s is phone over here, I try to cast, let's say, iPhone 6s. Now, would this compile or not, according to what we learned? Is this upcast or downcast? Neither. Okay, let's make it explicit for you. Okay, first of all, you can see that over here, phone static type is enjoy. Okay, let me just use green to mark that. Static type is enjoy. Now, iPhone 6s over here that we are trying to cast that into, over here. This one over here, it exists over here. It's neither an ancestor nor a descendant for the static type, so it will not compile. Okay? So for a cast to be compilable, that means you can either try to call more methods or fewer methods. Okay? That's basically what a cast will allow you to do. Questions? Can we cast iPhone 6s to iPhone 6s Plus? No, you cannot. Let me write it down. Okay? Can we do that? Okay, let's try that. If we have iPhone 6s, let's say I'll just say P for now, and then equal to something, okay? Again, doesn't matter. Now, your question was, can we do something like this? iPhone 6s Plus, and then I'll say P2, okay? Can that be iPhone 6s Plus over here, and then I simply put P? That's your question. Okay, let's try to be systematic when we do this. First of all, what's the static type for P? iPhone 6s. Okay, iPhone 6s, that's a static type, which is over here. And now we are trying to cast this into iPhone 6s Plus, which is over here. It's neither its ancestor nor its descendant. It's a sibling in this case, right? Well, just nothing to do with it, right? So it wouldn't compile. Okay. You can also download some sample code, which I made available to you. It's not really this example there, but I just only make a few classes to illustrate exactly the point. You should really go over both the notes and the sample code. Okay, let's go back. Okay, that's exactly what this page is talking about. You can go over them. Let's cover them already. Okay, now let's talk about, okay, up to now we talk about what it means for a cast to be compilable, which means you wouldn't get any errors from the Eclipse compiler. But now, even if you get things to compile, it doesn't mean you're not going to run into exceptions. Okay, now we're going to see exactly this. Okay, now let's see that. I'll give you some example here again. Now let's try to imagine this since we are pretty familiar with this example already. Let's say I got students, Jin, and then non-resident students. Okay, static type is students, dynamic type is non-resident students. Now, if I say this, first of all, line number 2, let's try. Would line number 2 compile or not? I'm talking about compilation. Okay, let's try to see that. There's 2 parts you're going to judge. Okay, first of all, when we cast Jim into resident student, the right-hand side, it will compile because Jim's static type is students. And are we doing upcasting or downcasting? Downcasting, exactly. Okay, that part compiles. And then we temporarily change the Jim static type to be resident students on the right-hand side. So now, resident students, the temporary static type, is a descendant class of the left-hand side, right? So now that one also compiled. Okay, it's set in the slides. Okay? Now, so far so good. Nothing so interesting. But now, and then we say RS that set premium rates, right? And now when we say RS that set premium rates, now think about this. RS is pointing to what kind of objects at the moment? What's the dynamic type for RS? Non-resident students. Does non-resident student have the premium rate attributes? No, it doesn't. However, things compile. So you can treat the compiler quite easily. Okay, you see, basically what we said before about the rule, you can either do upcasting or downcasting. However, you can see somehow you're casting to some class which your dynamic type simply cannot meet the expectation. Okay, let me just make it clear to you. First of all, Jim is pointing to a non-resident students. What you can really get from non-resident student will be the student attributes and also discount rate. That's all you can get. However, this thing over here simply just compile because the only thing the compiler checks is the static type of Jim. It does not care about the dynamic type. As I said before, figuring out the dynamic type is undecidable. Okay, you simply cannot do it. Okay, now everything compiled, but if you run it, you're going to run into so-called class cast exception. Okay, that's one thing to note. Okay, you can go through everything here, and then the last point here is the most important part. So the reason that for line number 2, we're going to run into the class cast exception is because when Java try to execute this code here, which compiles, when they reach line number 2, they will see that, okay, the dynamic type of Jim at this moment is actually non-resident students. However, the non-resident students cannot actually meet the expectation from resident students, which needs premium rates, right? But the non-resident students as a dynamic type, it does not have premium rates. So that's why it does not compile. Okay? Again, I'm just giving you one example. I'm going to present to you the rule as well. Yes?
So first it says it compiles.
It compiles, but it will run into trouble.
Yeah, but where does this cast exception?
Okay? At the runtime. Okay. Yeah, at the runtime. So first, 1, 2, and 3, they compile without any problem. So you can execute in the Eclipse. However, when you reach line number 2 over here at the runtime, it's going to give you a class cast exception. The rationale behind that being, well, Eclipse will simply tell you they cannot really convert, cannot cast from non-resident student into resident student, right? They will simply say that. But to really see why, think about what we can expect from resident students. We can expect premium rate, for example. However, the actual dynamic type for Jim is actually non-resident student, which does not have premium rates. That's why it should be a class cast exception. Okay, that's just one example. Let's see another one, and then we'll see more. We'll see rules, okay? Just to make the typecast rule complete. Now let's say again, let's say we got smartphone and then a phone. So we got Galaxy S6 Edge Plus. Remember, that's the phone which has side sync, okay? Just remember, okay? Now let's say we got iPhone 6s Plus, right? It's a static type, the new variable. For here, over here, first of all, would this compile or not? Line number 2. And now you should really know how to judge. Again, the static type for a phone is smartphone. We are doing downcasting, right? We're downcasting from smartphone into iPhone 6s Plus, which again is completely okay. However, the problem for this is, even though it compiles, when we reach the runtime, what's going to be the problem is, since a phone is actually pointing to a Galaxy phone, which does not support any of the iPhone 6s Plus method, for example, 3D touch, it does not support. So that's why it's going to run into trouble. Okay? Guys, are you okay with so far these two examples? Please ask questions before I give you the rules. Yeah.
Instead of declaring the static type as smartphone, you just declare right away as iPhone 6s Plus. Are they going to compile or not?
Okay, good question. So Sammy's question was, let's change line number 1 a little bit. Let me avoid some distraction. Let me only get line number 1 left. Okay? Let's change the green one, the static type, to be iPhone 6s Plus. Would it compile? No, because how do we judge? We want to know the new dynamic type, which is Galaxy S6 Edge Plus, should be a descending class of iPhone 6s Plus. But if you look at the hierarchy, they have nothing to do with each other.
So my question is, so now you said the compiler doesn't know the dynamic type, how does it know in this case?
Because, remember, okay, very good question. This is the very special case because we talk about there are two ways for you to change the dynamic type, right? One is by using the new keyword, in which case you're assigning some new dynamic type right away. That's a special case the compiler can check right away. But if you want to say you do lots of variable reassignments, in that case, the compiler cannot keep track. Yeah. So you want to just review the two approaches to changing the dynamic type. So this is the most obvious one. Okay. Okay, guys, if you have no questions, now you deserve to know what would be the general rule to make sure a cast compiles, which we know we can either do upcast or downcast in the compile time. Okay. Now, how can we also guarantee there will be no class cast exception? How do we know? Okay. So now, since we talk about runtime, whenever you want to know the runtime behavior, you have to consider dynamic type as well. Okay, as a programmer. Okay, I'll show you. Yes, questions. What is? Oh, good. That's a typo. It should be for Hyun, not RS. Thank you. I'll change that. That's the evil of copy and paste. Okay. Okay, good. I'll change that. Yes, very good. Okay, now let's see how we can do it. Okay, again, let me give you some intuition before I give you the rule. Okay, on that. Okay, let's see this. Now, let's say again, I have Android over here. Now, since we're going to talk about both compilation and runtime behavior, so now let me bring dynamic type into play. Okay, I'm going to say Android. Let me say phone. I didn't say P over here. Is new over here, and then I would say, what about let's use our friend over here. Let's say it's still Galaxy. Okay, new Galaxy S6 Edge Plus. You know what? Let's make it more interesting. What about I simply do Samsung? Right, just one level up, which is okay. Okay, so now you can see that. Let me just highlight to make sure you exactly got it. Android is a static type. And then we have Samsung is the dynamic type. Right? What I said before was, for the class cast to compile, these are our choices. For things to compile, let me just use green. For things to compile, we can either do upcast or downcast. Upcast or downcast. Okay? Now, let's try things like this. Okay? I'll give you one thing, one cast that's going to be okay, and one cast that's not going to be okay. How about that? Okay? Let's try two. Okay? So now, first of all, let me just write down the cast directly. Okay? I can either cast P to be, let's say over here, Samsung. Okay, this is cast number one. Okay, What about cast number 2? That's a down cast apparently, right? So let's say I'm also trying to cast into Galaxy S6 H plus, and then cast P to that, okay? First of all, let's convince ourselves, number 1 and number 2, they both compile, okay? Because static type of P is enjoyed. Samsung is a descending class, so downcasting. Galaxy S6 H plus, also a descending class, also downcasting, okay? Both compile. However, one of them is going to give us class cast exception. 1 or 2? 2. Can you just tell me intuitively why? Intuitively. Yes, please.
Because Galaxy H plus expects
Side sync. However, yeah, exactly. Okay. Now, let me just use more annotation. Let's say yellow is the type we're trying to cast into. Number 1, we're trying to cast to Samsung over here, which happens to be the dynamic type. And for number 2, we are trying to cast a little bit down, a little bit too much in some way, right? We're casting that into Galaxy S6 H plus. What does that mean? Currently, the dynamic type of P is actually Samsung, which means the most you can expect from that will be Samsung methods. But when you do the downcast a little bit too much, in that case, you cast Samsung into something that you simply just cannot meet the expectation. For example, if you cast if you cast P into Galaxy H6 Plus, in that case, this method here is simply not available in Samsung. Right? That's why it doesn't work. Now, can you just try to see if you can figure out the rule? So now we know that we can do upward casting and downward casting. Out of those that will compile, can you tell me a little bit smaller number of classes that will make it just to be runtime exception free? No, that's okay. What you just said was just do upcasting. I tell you what, if you only do upcasting, in that case, you're saying that only do upcasting, only this direction here, including itself. According to dynamic type. Okay, so now let's see this. When you do, first of all, whenever you do upcasting over here, you will always be okay, right? You can never, you are always narrowing down the expectation, so you will always be okay to meet the narrow expectation. However, when you do downward casting, you got to be careful. If you cast something that's actually somehow inconsistent with your dynamic type, in that case, you'll run into trouble at the runtime. Okay, so now the rule is, for a cast to compile, it can be either upward casting or downward casting. For a compiled cast to be runtime exception free, in that case, you can only cast only down to and including the dynamic type itself, which means it can cast to dynamic types itself or its ancestor. Okay, it's written on the slides. That's the general rule. Guys, I know it's sophisticated, but that's how compiler works. You should really know how things work. Again, the rationale behind this really comes from expectation, all about expectation, and whether the dynamic type at the moment can meet the expectation. If the dynamic type cannot meet the expectation, you got exception. Okay. Questions? Okay, this slide here, basically exactly what I said. You can also go over them. Okay, exactly. Okay, 2.1, 2.2, and 2.3, they're exactly the same. Okay. Okay, now let's do some exercise quickly. Okay, now let's try this. This will be something similar to what I will give to you in the exam. Why don't we try to rehearse? Okay, yeah. Now, first of all, on your piece of paper, do me a favor. So now, according to this class decorations over here, can you draw the inheritance diagram quickly? Just take a few moments, okay? That's exactly what you need. A, B, C, D. I'm gonna draw that in just a moment. Yeah, okay. That should be easy. I'm gonna draw that on my iPad in a moment, and I'll show that to you. Only class, no methods, okay? Because I want to use this example to show you more about cast, to strengthen your understanding. Okay, are we good? Okay, try. Then you should get something like this, right? Okay, well, whether B is a left child or is a right child doesn't matter, okay? Doesn't matter. Okay, very good. Okay, let's start, let's now, for this particular exercise, we're gonna focus on this particular hierarchy, okay? Intentionally, I don't give you any meaningful names. I simply give you A, B, C, D. I want you to be like a compiler in some way, right? Because I tell you what, if you really want me to give you some meaningful names, I want to give you something that's confusing. I might put resident student as A and student as B. In that case, if you simply memorize what we did before, you'll be wrong, right? That's my point, right? You don't want to memorize. Okay, okay, let's try. Now, let me present a question to you. Let's try together. Now, let's say we have line number 1. We say declare B and to be mu C. Will this compile or not? Yes, right? Yes, right? Because now, basically what you want to ask, if C is a descendant class of B. It is, right? C is a descendant class of B, right? Okay, let me annotate that. So basically you have, over here, we declare that to be B. B is a static type. And then we have dynamic type to be C. Okay, that's exactly what is achieved. Now, let's try this one here. I'm trying to do this one here. Okay, let me copy that over to the diagram, and then I'll show you. We can analyze that carefully. So we have D, E. Should this compile? Why? Why not? Anyone want to try? Yes, you want to try? Yes, I don't know your name, but you. Yes. Oh, you didn't want to. Okay. Yeah, that's fine. Anyone? Why does this not compile? Okay, Sammy, go ahead. Yes, correct. In this case, it's neither downcasting nor upcasting. In this case, you can see D, so the static type of B is actually B, right? In this case, D is neither an ancestor class nor a descendant class of the static type, the green one. That's why it does not compile. Okay, first of all. Good, very good. Now, that you passed the first test, that's good. Now, next question here. Okay, you can, just line number 2 does not compile. Okay, exactly the reason. Okay, now, question for you. This can be a little bit tricky, okay? Now, I want to make line number 2 compile. Do you think this line would do it? And try to see what this is trying to do. In some way, it's doing something to treat the compiler. I'm going to write on my iPad as well. And then, so what is it doing? It's doing upcast all the way to the top so that you can do downcast to any way you like. Right? It's okay. First of all, let's not worry about that's bad or good. You can write it, okay? First of all, let's see what we're trying to do over here, okay? Now, when you say you cast B into A, that's absolutely fine because A is already on the top. And once you have this expression over here, you can now downcast to any way you like. And then you can just downcast to D. You are trying to fool the compiler at the compile time. It succeeds only at the compile time. So this is actually the example I made in the sample code. You can go over that. I got also detailed comments there for you can go over. Now, we can see what he's trying to do, right? Upcast all the way to the top. You can, in theory, you can also upcast all the way to the objects, and then downcast to any way you like. Right? Again, it's a bad style because you are not really taking advantage of cast. You're just doing you're exploiting the the thing. Okay. Now, the thing is, this compile, okay? First of all, let's agree, it compile. Yes. Now, the question is, are we gonna get, no, we kind of fix the compile time error. Are we gonna get any runtime exception? That's the question. After this kind of trick to the compiler, are we tricking the reality as well? No, right? Again, as I said before, compiler is naturally very limited intellectually. If you can trick it, it doesn't really mean too much. Okay? So now, think about this. When you want to judge for a class cast exception, think about what's the dynamic type. Okay? Now, when I do this line over here, right? Again, what's the dynamic type for B? C, right? After all, the C object is still there. It's sitting there in the memory. We never change the object itself. Now, when you try to cast the object C dynamically, eventually into D. In that case, we are trying to cast, okay, the object here, C, into D. Over here. Oh, sorry, let me do it again. D over here. Do you think that's going to be a exception-free cast? No, right? Now, the actual object is actually C over here, but now we are trying to cast it so that it's going to meet all the expectation for D. In general, it's simply not possible. You can only meet expectation for yourself or your parents or your direct parents, right? But now D is like uncle in this case, right? So it's not really, you cannot meet the expectation there. Okay, guys, are we okay? So study this exercise here carefully. I know it's a little bit tricky here, but hopefully that will strengthen your understanding. So there are two issues here. First of all, I might ask you whether a particular cast is going to compile. If it doesn't compile, end of story. If it compiles, then we're going to ask whether if there's going to be some class cast exception at the runtime. Again, it's all about expectation. Okay? Okay, study this very carefully. I think that's worth knowing for sure. Okay, now, so now you might be wondering, so now what should we do then? We know that even though the cast we run in the compiler is simply just will simply just compile, but we cannot guarantee runtime exception free. How can we do a little bit better than before? There is a way for you to actually do some check, so-called instance-off check, which means let's say this. Before I want to cast into D, before I do that, I can always run a check. And this check is going to be checked not by the compiler, but by the runtime execution machine of Eclipse. Okay? I want to say, before you cast C into D for me, before you do that, do a check for me. Check if the object's dynamic type is actually going to meet the expectation of D, which means is the dynamic type actually a descendant class of the type you're trying to cast into. Okay? That's a general rule. Okay? That's the intuition. Now I'll show you the syntax very quickly and I'll write some example. Okay? Okay, what we can do is we can now simply say instance of. Okay, maybe you have seen that already, or maybe not. Basically, the instance of is the syntax is like this. Instance of is like an operator. Okay, it's going to return Boolean, either true or false. It's a binary operator. The left-hand side is going to be any expression, but for now, let's make it simple, just a variable. We are basically asking the following question to the runtime execution machine. Is the dynamic type of Jim, when you execute this particular line of code, is the dynamic type of Jim a descendant class of resident students? In this case, true or false? What's the dynamic type, first of all? When we go to line number 2, what's the dynamic type of Jim? Non-resident students. In this case, non-resident student is not a descendant class of resident students. Agree? That's what you will check. And then it's going to return false. That means we're going to bypass this problematic cast over here. Now let me change something here. Let's imagine that hypothetically, in line number 1, if I change the dynamic type to be resident students, okay, resident student, hypothetically. Now, when I go to line number 2, because the dynamic type is now resident students, is resident students a descendant class of itself? Yes, so you will evaluate to true. So that means I'm safe to do the cast. Okay, so the instance of check is only going to be done at the runtime, only at the runtime. And then somehow it's going to check for you whether the thing you're trying to cast into can actually meet the expectation of the cast type. If you can mean that it's a descendant class of that, then you will pass the check. Otherwise, you will bypass. Okay, that's the intuition. Okay, now these two examples are kind of easy. I'll let you follow that. Okay, just false and false for the previous problematic cast. Okay. So now this is, I just want to mention some general rule very quickly. Let's try some exercise as well. So this, it means whenever you got V instance of C, okay, basically when you check it, the dynamic type, again, we talk about runtime. Dynamic type of V should be a descending class of C. Okay, let's see example. Let's say this. After this line over here, we have static type of my phone being smartphone, right? And dynamic type is Galaxy S6 Edge. Okay, I'm gonna have the hierarchy over here handy for you. Okay, let's try that. First of all, let's try this. If I say my phone instance of Android, true or false? Okay, now let me just do some annotation for you, because now what really matters for instance of is that the dynamic type. So I'm going to annotate is S6 Edge. Okay. So this is the dynamic type over here. Okay. Now, basically checking this is basically asking, is the dynamic type of my phone an instance of Android? In that case, yes, right? It is the descending class of Android over here, because Android is over here. Okay, it is. Okay, and then that will be true. What about the second one? When I say my phone instance of Samsung, yes, right? Because it's here. That's a descending class, right? Again, dynamic type. Okay, you can see the explanation there. What about when I say my phone instance of Galaxy S6 Edge? Yes, right? Because the class is descendant of itself. Very good. Okay, very good. So far, so good. Okay. Now, what about this? My phone instance of iOS. False, because iOS is here. So the Galaxy S6 Edge over here is not a descending class of iOS. So instance of would be false. That means it's not safe to cast. Okay. Okay, very good. One more. How about this one here? So my phone instance of iPhone 6s Plus. No, right? Because iPhone 6s Plus is over here. That's also not. So also Galaxy over here is not a descending class of that. So false. Questions?
So to clarify, basically it's because it checks if it's a descendant.
It's dynamic type.
Yeah.
Yeah. Correct. Yeah. So instance of is a runtime check. A runtime check. Yeah. Okay, very good. And now, so basically this slide here you can also go over. This one simply show you that I want to know that, first of all, you can see, I'll just show you one case over here. You can see now the dynamic type is Samsung over here. Okay, so it's a slightly different example. Okay, I'll just go over there. Okay, so dynamic type is Samsung. Okay, I'm gonna put it there. Dynamic type is Samsung over here, dynamic type. And now, if let's say I want to cast Samsung, I want to cast the my phone over here into Samsung. Would it be safe for me to do that? In this case, I can simply do an instance of check. In that case, would the instance of in line number 3 return true? You would, right? Because Samsung over here is over here, just itself. So it'll be okay to cast. Okay, so that will be return true. Okay, so I can do cast. On the other hand, I'll show you one thing that wouldn't work. Now, before I cast my phone over here into Galaxy S6 Edge Plus, before I do an instance of check. Okay. Now in this case over here, you can see the instance of over here. Okay. So it's actually over here. So now is the instance of going to be true or false? Line number 6. Be careful. Line number 6. Line number 6. Think about what's the dynamic type for my phone. My phone dynamic type is Samsung. Is Samsung a descendant class of Galaxy? No, right? The red one is not a descending class of the yellow one. So it's going to be false. Okay? So this is kind of the practice you're going to keep doing. Okay, you can follow the rest. Okay? So that means line number 6 is going to be false, which means it's unsafe for you to do the cast. You can do that before you try to do the cast. Okay? Okay, very good. Guys, I will pause a little bit. So any questions until now? This could be the worst part for today. I think we are getting there. Okay. Okay, if no question, let's go on. So basically, for this part, static type and polymorphism, basically that one just repeating basically the same example. I'll leave then just this part to you. I can go to the next part. Okay. So polymorphism and dynamic binding just show you that with different static type, it restricts about what methods you can call expectation. Okay, I'll let you go over them. Okay, so now I'll just go to the next topic. Okay, okay, everything I have talked about already. Everything. Okay, now it's a new topic. Okay, slightly new extension. So far we talked about if you do some simple assignment or do simple cast, how you can decide a cast is compilable, and also any compilable cast would result in any runtime class cast exception. That's what we have learned. Now, let's put something even more useful. When you design your methods, you have arguments, you have parameters, you also got return type. What if the return type themselves or the parameter themselves have some inheritance hierarchy involved over there? How should we deal with them? How do you judge if something will compile when you pass a descendant object or when you try to pass some ancestor objects? Okay, okay, let's see that. Now, first of all, let's see this. Line number 2. So I have a class called student management system over here. Okay, line number 1. And then I declare number 2, students array SS. And then, okay, just this line is the most important thing to understand for this slide. So what does line number 2 mean, first of all? It's really important to see that. I'll give you 2 options, okay? 2 options. Let me just go to iPad over here. When I say things like this, when I declare students array SS, I got 2 choices for you. This means static type of each item in SS is students. Number 2, dynamic type of each item in SS is students. 2 options. One is about static, the other one is dynamic. Do you think both are true, or one of them is true, or none of them are true? None of them? One of them, yes, good. Which one? Well, to really, this one is no more complicated than this. If I simply say this, I'm pretty sure you will be confident to tell me. If I simply say students and then S, do I mean that S is of static type students, or do I mean that S is of dynamic type students? Static type, right? Exactly. So now, the only difference is, now we talk about array over here. Array is simply just a collection of values. So now we are trying to do decoration. Whenever you talk about decoration, you're really making something about static type. So now we're declaring basically element 0, element 1, element 2, all the way to element ss.length minus 1, right? Now we're saying that for every element in the array, their static type is simply just students, right? Okay, let's get it clear first. So number 1 is right, only number 1. Yes? Dynamic type will get there. I'll get there, yeah. Now let me just, I'll get there, otherwise I'll confuse you. Okay, first of all, let's understand this decoration here. It should be no difference than this one here, right? We're just declaring something. Okay, good, let's go on. And we also got a counter, okay? Should be a pattern you're very familiar with, a birthday book, point collector, etc. Now, let's say we declare a method over here, add resident students. And then I put resident student over here, and then RS. Okay, now, first of all, tell me something. When I declare resident student RS here, am I trying to say the static type for RS should be resident students? Or am I trying to say the dynamic type of RS should be resident students? 1 or 2? Static type, right? 1. Okay? So now I know that RS is of static type resident students. Now I also know that every element in the array SS has static type students. Do you think this assignment over here, SS at position C, the counter, is assigned to RS? Do you think this will compile or not? Okay, okay, I think it deserves some illustration here. Let me just put it on the iPad. Okay. Okay. Let's say this. First of all, let's go back there. So we got students over here, and then SS. Okay, and then we say at. Okay, we got void RS, and then we have resident students. Just RS, resident students, and then RS. Over there, we got SS at position C is assigned to RS. And then also the counter plus plus, right? That's what we have. Yes? No, it's okay. It's an attribute. So you can just declare the attribute over here. That's fine. Yeah. Okay, now let's try to analyze this. I'll help you a little bit. Okay. Now, for you to, excuse me, if you want to know if this line here will compile or not, what you got to do is figure out the static type for the right-hand side. What's the static type for the right-hand side? Resident student. Where did you find it? Over here, right? Good. So now static type is resident student. That's how we find it out. Okay. Now, what is the static type of this? Which line did you find out? One over here, right? So because we know that every element in the array is of static type student. So this is of type students, static type. Now we can apply what we know already. Now, how do you judge if should this assignment compile? Yes, because resident students is a descendant class of students. Not too bad, right? The only thing that's a little bit new to you is when I declare student array, that means every element is of static type students. That's the only thing that's new. But let me say a little bit more. Yeah, Raymond, before I ask you a question. Now, think it this way. So when I say RS is a descendant class of student, that's true. However, think about the dynamic type for RS might just be resident students. Right? In that way, I'm trying to store something like a resident student into the student array. Okay? Okay, I'll get to there. It's not that important at this point. Any question until now? I'll go one step at a time. Yes.
So if we were to initialize the array,
Uh-huh.
what would we initialize the array?
Yep. So now how do we initialize the array? For example, I can simply say here, just make things simple. Okay? You can simply say new, just the same, students. Maybe 10. Okay, that's something you can do in the constructor. Okay, good. Yes? Okay, so now that's something I didn't really include in the slide, but let me just give you some idea. Remember we talked about point collector, right? When we declare the points array, we say point, square brackets, and then points. We do not initialize there right away. We only do initialization in the constructor. Right? So now here I just don't have space to put a constructor, but that's something you should do. You just initialize it to be something like this. You can say in the constructor, okay, let me just make it precise, otherwise you might still have doubts. Let me just erase this, okay? Now what you should have is something like this. In the constructor for the student management system, right? So we talk about student management system here. So now student management system constructor over here, this is something we should do. We should say SS over here. SS is assigned to simply a new array, right? I'll just put new array here, and then students. And then put a size, for example, 10. No, because I put this in the constructor, which means whenever as soon as you initialize a student management system object, it's going to initialize the array. However, if you didn't put this line over here, you're going to run into trouble, right? Because that means the SS will be of value null. Okay, good. Okay, let's go on. Now, you shouldn't be too uncomfortable about this line here, right? Let's see this. Over here, you can see the parameter. We just have another method here, add NRS. The parameter type, the static type is non-resident students, and then NRS. And now, would this line compile? Because the static type for NRS is static type for NRS. Non-resident student here, right? Okay, okay, you're okay, right? So NRS over here was declared as a parameter, non-resident students. Now, SS at any position there of static type students. Now, non-resident students is a descendant class of students. Okay. Similarly, if I have student over here, and then you can see I'm trying different parameter type just to show you. Now, will this compile this line here? Sure, good, because static type of S is students, as declared over here, and students is a descendant class of students. Okay, so you can see that by having these three methods in line number 3, 4, and 5, it gives us lots of flexibility of adding student into the system. I'm going to show you more, okay? Now, let's see this. Now, first of all, this is just a repetition from what I said before. What I want you to see is this. I'm going to write it down on the iPad. Something to do when you call a method with object, we copy the address of the object, right? That's what we talked about before, about call by value, call by reference. Okay. Now, what I will do is I'll just have a new page over here, and I will show you. Oh, actually not above. Okay, I'll add another page below, I think. Okay, let's try that. Let me give you one example here. Now we got class student management system over here, and then we have students over here, SS, array of course. And then we have void, let's say add RS, let's say add S, okay, how about that? Add students. And then, excuse me. And then over here we have things like students. And then we have S. Okay? And inside we simply do SS of position C is assigned to S and then C++, right? That's what we had before. Now, let's think about how we can use this, and I'll give you some idea, okay? How to judge. Now, let's say we got another class over, let's just say we got a block of code to test. Now, first of all, we have SMS. SMS is a new system, student management system here. Let's assume the constructor has already initialized the array like before, okay? That's not an issue for this example here. Now, if I do the following, if I say resident students over here, RS is new. Resident students over here, let's say Rachel. Now, if I try to do the following, if I say SMS dot add students, and then I put RS over here, okay? Do you think this line over here should compile or not? Yes, no, right? I heard no, okay. How about vote? Yes? No? Maybe a little bit more yes than no, that's good, okay. The answer is it will compile. However, we gotta learn why, okay? Let's try to go step by step. What do we know about passing the arguments? What do we know about that? Okay, thinking this way. Remember what I did before. When I say call by, well, when we copy the address as the argument, right? Basically, conceptually, we are trying to replace, so since we are trying to call this method over here, add students and then add students. And then somehow we're passing this argument over here, and then we're trying to replace that for this parameter. In fact, the way Java implements this internally is by using assignments, okay? Let me ask you this, try to see this. Are we trying to do, let me give you again, choices number 1 or 2. Number 1, are we trying to do RS is assigned to S? Or are we trying to do S is assigned to RS? Right? Number 2, right? Because what does number 2 means? That means, let's say if currently RS is pointing to our Rachel object over here, RS, right? Ratio. Now, we say that in order to call this method here, we're going to pass RS as the arguments. And we are going to call this by copying the address of this object rather than copying the entire objects. So that means S is going to copy the reference of RS. That means S is going to point to the same objects. So that's exactly what we learned previously, right? So that's why when we say S is assigned to RS, we now go back to our comfort zone, right? So now, should number 2 compile or not? Yes, right? Because static type for RS is RS over here, right? Static type for S, students. Resident student is a descending class of students. So now, the only thing you should really try to get yourself convinced, when you try to pass arguments, you're really trying to do an assignment over there. You're trying to assign the arguments into the parameter, but not the other way around. As long as you get the direction right, you can apply the same rule again. Okay, let's try, shall we? Okay, then at least we can finish this today, and then I can continue on Tuesday. Okay, let's try that. So let's say we got S1, we got S2, we got S3. Okay, I'll let you judge. We got resident students, non-resident student. We got 1, 2, 3, 4, 5 objects over here. Okay, and we got SMS, the student management system here. Now, would this compile? You will? Are you sure? Let's think about this. At RS, let's review. At RS has the parameter type resident students, right? So we are trying to assign something to RS, right? Now, I'll let you try again. No, it shouldn't, right? Because static type for S1 is students. You cannot assign student into resident student. Good. Okay, how about this one here? But you see the dynamic type here is resident students. Should it compile? Why? Static type, exactly. You don't care about dynamic type. You don't care. That's why I don't even bother to highlight them over here, right? How about this? Because non-resident student is not a descending class of students. Oh, sorry, resident students. Okay, you can see my point. Now, what about this? Right? Because finally we got RS, in which case the static type is descending class of that. Good. How about that? Nope. Okay, you got the idea. One more. Let's say we try as students over here as 1. You'll be okay, right? Now, question for you. I know that this will compile. If I try to execute this, that means I'm adding objects of dynamic type students. Agree? This line here, when I say S2, would it compile? In some way it should, because you see the parameter type for S student is simply student, the most accommodating type. In this case, what dynamic type I'm trying to add? Resident student, right? You can see I add the first object, dynamic type is students. Second object, dynamic type is resident students, right? Compile, S3? Yes, right? Because non-resident student, student here, again, is a descending class of student, right? This one here, RS. Right? You can see basically RS and RS, they are simply descending class of the student class there. Okay, any questions? Okay, I think I'll stop here and then I'll continue on Tuesday. We got only 2 classes left. I'll do as much as possible. Okay.